Hello, Nick. How are you doing?
Hey, everybody. Good afternoon. Good evening.
Great to have you here. I'm really excited. Nick is connecting to us from Germany, correct?
That's right, from Berlin.
Yeah. So I had the pleasure to see Nick last year on the Lead Dev Berlin, and it was awesome. So that's why I'm so excited. Nick is passionate about post-incident reviews, process, learnings coming from it. He works at Microsoft, working on Azure. Nick, welcome. Great to have you today. Are you ready?
Michelle, thank you very much. I think I'm ready. Okay, we'll find out, won't we?
Yeah, switch off the presentation and yep, the stage is yours.
All right. Thank you very much for that lovely introduction. It's a little bit strange giving a talk to a bunch of people who I cannot see, but I'm excited to be here. So I'm going to share some thoughts with you all today about how we can learn more from incidents. And before I get started, I want to make one thing clear, which is that although it's just me talking to you today, this talk is actually a joint effort. It was originally co-written with my colleague Jessica DeVita for an internal conference at Microsoft. Jessica has since moved on from Microsoft, but the talk is still part hers. And you should give Jessica credit for all the deep insights in the talk, and you can blame me for the bits that don't make sense. So as Michal said, I'm an engineering manager. I work on Azure, or Azure as my American colleagues call it. And I'm excited to share this talk with you today because improving how we learn when things go wrong is something I'm quite passionate about. And I'm hoping to share some of that passion with you today. We have a lot of fairly old and broken ideas about how people do their work in our industry, and particularly in the area of operational work. That's work where we're running production systems and where we typically deal with incidents on a daily or weekly basis. But I'm getting ahead of myself. I'm going to start today with a story. And the story is about this plane. And I'm not going to tell all of the story right away. I'll tell you the first half of the story, and we'll come back to the second half later in the talk. So this plane, this aircraft, is the B-17 Flying Fortress. And during World War II, this model of aircraft was involved in a series of accidents. We don't know all of the details of these accidents. It was during the World Wars. There was secrecy around military operations, and not all of the accident investigations are public, but we do know that it wasn't a one-off event. There were multiple events, and they were similar in some regards. And in each case, what would happen is this. A B-17 like this one would come into land, and either shortly before landing or shortly after landing, what you see here would happen, which is that the landing gear would retract unexpectedly, and the plane would end up belly down on the runway or belly down on the taxiway. And in each case, military investigators would try and understand what had happened. And they would find no evidence of any mechanical or electrical failures. And thus they would conclude something that I think might be familiar to some of you who are involved with incidents in our industry. They concluded that this was due to human error. Although in those days they called it pilot error because it was the pilot that they assumed had made the mistake. Does this story raise questions for you? I'll come back to it later on, but for now, I want you to think about two things. The investigators were on some level correct. No mechanical or electrical failures had occurred in these incidents. But despite what they concluded, and despite the reports they wrote, the accidents kept happening. So I'm going to propose that something in that investigation is missing, and we'll come back to that later. So you'll learn more about the planes in a bit, but for now, let's look at the structure of the rest of the talk. First, we're going to consider a question. Why should we want to learn more from incidents? The answer may seem obvious to you, but I have a twist I want you to consider. Then we're going to talk about 4 common traps that we all fall into during incident investigations. And these are traps identified by a community of researchers who have studied systems similar to ours in other industries. And we'll hear more about them later. And then we're going to talk about 4 helpful practices, steps that you can take in your teams starting tomorrow, which will help you to learn more from incidents. So let's get started. So why should we want to learn more from incidents? If you were all in a room in front of me, I would ask you for suggestions, but I can't do that, sadly. When you do ask people this, the answer that I hear most often is to prevent them, to prevent things from going wrong in the future. And that's a perfectly reasonable answer. But I would follow it with another question. Can we prevent all incidents? And here's the thing. No. Most of the systems we work on, and I'm lucky to work on a very interesting system, Azure, most of these systems are complex systems. What does that mean? That means they're composed of many different parts, and the behavior of the system as a whole comes not just from the parts themselves, but from the interactions between those parts. And the thing about complex systems is that they behave in all kinds of interesting and counterintuitive ways. And I'm sorry to say that they're never 100% reliable. The gentleman on the right of this slide is Dr. Richard Cook. He is an anesthesiologist or an anesthetist. In the UK, he would be, and he's American. And he's a researcher as well. And he has spent decades working on safety in complex systems, and specifically on patient safety in the healthcare system. He wrote a paper quite a while ago now called How Complex Systems Fail. And there's a link to it on this slide, which you should be able to type out. It's relatively short. I would strongly encourage you to go and read that after my talk. It's very short, and he explains in very clear language what is common to complex systems in all fields, from healthcare to software operations. And I'm going to share just a few of the insights from that paper with us today. Complex systems contain changing mixtures of failures latent within them. What this means is that your system is never fully functioning. It's always in a state of partial degradation. But one thing you can take some hope from is that complex systems run in degraded mode. A degradation in a complex system doesn't result in instant failure. Your system works when it's in degraded mode. But unfortunately, catastrophe is always just around the corner. And this is something that those of us who work in these systems are familiar with. These systems can fail in quite spectacular and unexpected ways. But what does this mean for us? It means that the complexity of these systems implies that failure is in the long term unavoidable. And that in turn means that there are 2 things that we need to think about. Prevention, yes, on the one hand. But also, if things will eventually and inevitably go wrong, we also need to think about our ability to respond. And these things are interlinked, they're connected. I don't know if any of you have ever worked on a system where you've introduced some automation or some bot or some rule system to fix a problem. And that automated system has worked most of the time. But when it failed spectacularly, and it made it harder for people to understand what had gone wrong. And this is the thing that we need to realize. Whenever we're working on these systems, we're not working on a purely technical system. We're working not actually on the system, but in the system. And our systems and the things that we care about in them actually include the humans who work on them. And how the humans respond and react when things go wrong is as important as preventing things from going wrong in the first place. And this means that language matters. This may be very surprising, might not be where you expected I was going, but it turns out that if we want to truly understand what's happening in our systems, the words we use when we investigate them affect how we think about what happened and can drastically change what and how much we learn. And this isn't simply me making this assertion. This is a finding that comes from research in safety-critical industries such as aviation, medicine, search and rescue, firefighting, and more. Collectively, this field of research has become known as resilience engineering. And we'll have a lot to learn about resilience engineering in the tech sector. We're just at the start of our journey. But to get you started, I'm going to share 4 common traps in incident investigations identified in the resilience engineering literature. And we'll start by revisiting the story of the B-17s. Were you satisfied by the explanation I gave earlier for these B-17 accidents? Pilot error? Well, this man wasn't. This is Alphonse Chapanis. He was, during the Second World War, a military psychologist. And he was asked to investigate this series of accidents and try and understand what was happening. He noticed that these accidents were unique to the B-17 and a small number of other aircraft. He also noticed that the C-47, a Skytrain, which is a cargo aircraft in use during the Second World War, there were thousands of C-47 Skytrains deployed in Western Europe, and they had never suffered a similar accident. So what was the difference? He interviewed pilots of B-17s, and he went and looked at B-17 cockpits, and this is what he found. What you're looking at is the central console of a B-17. On the left, a drawing from the Boeing manual, and on the right, a modern reproduction. And if you look carefully, you'll see that switch 5 on the left is the switch to retract the gear, and switch 6 on the left is the switch to retract the flaps. Now, I don't know if any of you know how to fly a plane, but when you are landing, and particularly when you're rolling along the runway and along the taxiway off to your parking stand, your flaps will be extended because you will have had them extended for landing. And so what was happening was that pilots were reaching down to retract their flaps for parking and accidentally retracting the gear. These switches were too close together. They had the same mode of operation. They were simply too easy to confuse one for another. And so Chapanis tried something. He glued a little rubber wheel to the switch for the gear and a hard angular flap to the switch for the flaps. And the accidents stopped happening. Chapanis is now known as one of the founders of the field of ergonomics. That's the study of design factors in human performance and not just about your desk chair. And he had a simple observation that the design of the cockpit could affect the likelihood of human error. This has gone on to inform the design of all modern aircraft. This is what the gear and flaps controls look like in an Airbus A320. Their design, known as shape coding, is now mandated by federal law. So I've told you this story to make the single most important point I have for you today, which is that human error is a lie. Humans do make mistakes, but system design, organizational context, personal context, these things affect when people make mistakes, how they make them, and what the impact of those mistakes are. Human error is a symptom and not a cause. Human error is problematic in investigations because it causes us to lose sight of the fact that what the human did made sense to them at the time. If we want to learn, we have to learn not to stop investigating when we find a human error. As the story of the B-17s demonstrates, it's just beyond the human error where we start to learn interesting things about our systems. Now, the second trap. Oh, I'm not there yet, sorry. So when we hear human error, we need to look deeper in order to understand how our systems are working. Now, the second trap I want to talk to you about today is called counterfactual reasoning. You might not know what that means, but you've probably heard somebody engaging in counterfactual reasoning before. If you hear someone say that somebody should have done something or could have, would have fixed the problem if they had only, or that a system failed to do something, that's actually counterfactual reasoning. And what that means is that we're telling a story about a series of events that did not occur in order to explain a series of events that did. And you'll hear this in phrases like, the engineer failed to check that the config was valid before they deployed, or this problem could have been picked up in the canary environment. And the problem with counterfactual reasoning is this. If we focus on things that didn't happen, we're taking time and thought away from understanding how what happened. So the problem was not detected in the canary environment. Great. How was it detected? Does the canary environment usually pick up problems like this? Ask questions about what did happen, not what didn't. Trap number 3 is the use of normative language. Normative language can be harder to detect, but often adverbs will give the game away. If you hear somebody saying that something was done inadequately or hastily, that's normative language. Normative language often implies that there was an obviously correct course of action that operators should have taken, and judges the actions of those operators with the benefit of hindsight. The problem here is that the outcome of the decision that they made is the one piece of information that was unavailable to the operator at the time they made it. We know that. So we can't judge decisions on the basis of outcomes and expect to gain insight like that. I would just note briefly that normative language can also be used in the opposite sense. It's not just a negative thing. People can praise operators for having acted appropriately or with good judgment, but often that judgment is again made with the benefit of information that the people in question did not have, and so again falls into the trap of making an assessment of somebody's decisions on the basis of the outcome rather than on the basis of what they were seeing at the time. So if we accept these post hoc judgments, if we accept that normativity, then we will probably neglect to understand how the decisions of those people made sense to them at the time. And this is the thing you have to hold on to. Those decisions did make sense to them at the time. If they hadn't, they wouldn't have made them. So ask not, don't say, the relevant code was reviewed hastily, and instead ask about the context that people were working in. What have the previous 48 hours been like for your team? Tell us how this normally works. What were you looking at when you made that decision? And that brings me to the 4th trap. The 4th trap is my favorite trap, and it's what my colleague Jessica DeVita likes to call the meddling kids trap. And it's called mechanistic reasoning. Mechanistic reasoning is built on the idea that we work on systems that are basically functioning correctly. If something has failed, that can only be explained by a component within the system which wasn't functioning as expected. If only those meddling kids hadn't gone and deployed that broken config, everything would have been fine. The problem here is that this is simply not how our systems work. I'm going to ask you to think about this question for a minute. If you or your team run a production service, think about what would happen if you were told today that your team couldn't touch that system anymore. You can't make any deployments. You can't change anything about the running system. You can't log into any production machines to fix anything. How long would your system keep running? A day? Probably. A week? Possibly. A month? A year? The reality is that most of us work on systems where we know intuitively that if we couldn't touch them, they would eventually fall over. And what that demonstrates is that the only reason our systems are up and running in the first place is because of the actions of humans in the control loop. It's only through human action and capacity to adapt to changing circumstances that the system works at all. So I'd argue it's pretty silly then to conclude that the system was, quote, basically working if it hadn't been for those meddling kids. The problem with mechanistic reasoning is that it leads us down a path where we believe that finding the faulty human is equivalent to finding the problem. Unfortunately, at least unfortunately for the investigator who's fallen into this trap, that same faulty human has been improvising and adapting to keep the system running for weeks and months. So perhaps there's more for us to learn here. I hope I've given you some examples of how the language you use and the questions you ask can be critically important to determining how much you learn when investigating an incident. And we've identified a few traps, things to avoid doing when investigating. Perhaps you're now asking, what should I do instead? And so now, in addition to the 4 don'ts, I have 4 do's, specific recommendations for you to take back and practice in your teams. The first is to run a facilitated post-incident review meeting. So many people I talk to think that an accident or an incident investigation is about a single person writing something up in a Word document or a Google Doc on their own. I promise you, you will not learn that much that way. So get participants into a meeting with a facilitator to ask questions and review what happened in the lead up to and during the incident. These meetings don't have to be marathons. In fact, I would say they shouldn't be marathons. You need people to want to come to them. Most of the time, you shouldn't go over an hour, and 90 minutes, honestly, is the longest most of us can concentrate and participate effectively in such a meeting. If you're worried about making effective use of that hour or that 90 minutes, prepare. Treat these meetings as if they're expensive meetings. They are. So sit down and talk to the people who are involved in the incident one-on-one in order to understand what happened from their perspective. And you can use what you learn in those one-to-ones to sketch out the timeline of the incident and gain some sense for where you want to ask more questions in your facilitated incident review. Now, it's important that if possible, your facilitator was not involved in the response to the incident. You'll learn a lot more if the person facilitating isn't seen as having a personal agenda or a professional agenda in telling the story of the incident. And depending on your organization, it's not usually a good idea to allow managers in the room. I'll have a suggestion a bit later for what to do if you have managers that feel they need to be involved in this process, which is common. And the last thing I'd say on this one is, if you have a lot of incidents, you don't have to do this for everything. Start small, pick 1 a month, and don't necessarily pick the big scary incidents. Pick interesting incidents. Pick incidents where people were surprised. Okay. The next helpful practice I have for you is to ask better questions. Now, obviously, that's a pretty broad piece of advice, so I'll get a bit more specific. Asking why questions will often put people on the defensive. Now, this might seem silly to you, but unfortunately it's true. If you ask people why they did something, the assumption is that they did something wrong. So prefer how questions. Don't ask, why did you do that? Instead, ask, what factored into your decision to make that change? Don't ask, why wasn't this caught in Canary? Instead, ask, how effective is our Canary environment at catching this sort of issue usually? And remember that each participant in the incident is likely to have had a slightly different view on events. And so when you're asking questions, ask questions that expose these multiple views and interpretations. You'll often find that that's where some of the most powerful learning comes from, as participants discover that they were all seeing slightly different things happening at the same time. You'll also often learn as much by asking about how work normally happens as you will by asking about the specific incident in question. I've found, and my colleagues find often, that an action which is deemed to have caused an incident has been part of normal operations for months or years, and exposing this can raise all kinds of more interesting questions about what's really happening in your systems. For many more suggestions on how to ask better questions, I would recommend reading the ETSI debriefing facilitation guide. There's a link here, and there'll also be a link in the resources at the end. I will say that learning to ask better questions, learning to facilitate well, is a lifelong skill. This is just a very brief introduction. And my third recommendation, our third recommendation, in fact, for you, builds on key insights from the resilience engineering community. Far from our view of incidents as one-offs or products of extreme conditions, I hope you now understand that when you view incidents as products of a complex system, they're normal. And in most complex systems, things go wrong for many of the same reasons that they go right. So ask about that. Don't just ask about how the incident or how the outage happened. Also ask about how we recovered. Ask about how we got things from where they were broken to fixed. What insights were necessary? What skills were used to get the system back to working? What tools were useful? These are all good questions to ask. Another thing to think about is whether there was a critical moment, perhaps multiple critical moments during the incident when someone shared a piece of information that helped unlock the puzzle of what was happening. That person in that moment played a key role in recovering from this incident. So ask them, how did they know to do that? Where did the information come from? Share their expertise with the other people in the meeting or in the incident. And this is simply one of my all-time favorite questions to ask. Where did we get lucky? What worse outcomes did we narrowly avoid? I can tell you that in every incident review I have facilitated of any sufficiently complex incident in a complex system, this question always reveals fascinating things about how our systems work. Okay, and this comes back to what we said at the very beginning. We have as much to learn about how to improve our ability to respond as we do about how to prevent outages. It's your job as a facilitator to find out how incident response actually works so we can get better at it. And so, to my fourth and final recommendation, which is about when to discuss repair items or action items. You need to keep discussion of repairs out of your post-incident review. And this is controversial, and it's not something that many people in the industry do. If you don't do this, however, those discussions of repairs and mitigations will act as a distraction from the purpose of the post-incident review, which is to learn. So hold a separate meeting, maybe a day or two after your post-incident review, and perhaps with a smaller group, perhaps with decision makers, leads, managers. This will help you in two ways. First, it will help you in the incident review itself, because it's far too easy to jump to a conclusion if you're focused on how to fix something. If you defer the discussion of how to fix something to a later meeting, you can keep the focus in the post-incident review on understanding what actually happened during the incident. And the second way it'll help you is pretty simple human cognition. Well, simple is definitely the wrong word, actually, but it is a basic observation of human cognition, which is that sometimes a little bit of soak time will help you to identify better places to intervene in your system to improve. Just let yourself sit with what you learned in the incident review for a while. And I call these energy efficient repairs, minimum energy for maximum impact. Your subconscious will help you. You just need to give it a little bit of time. And I promised you this earlier, if management needs to feel involved, it's this repair meeting or action planning meeting that you should invite them to. They will learn about what is needed to address the issues raised by the incident without stifling the learning environment of a post-incident review. And they'll also be in a good place to understand what investment is needed to fix things in the future. So that brings me very nearly to the end. I'd like to conclude by reminding you of just three of the most important aspects of what we've shared with you today. First, we will always have incidents. 100% reliability is not achievable in a complex system. And 100% reliability is very hard to achieve even in systems that don't meet the bar of highly complex. And that means that our ability to respond effectively will always be important alongside ongoing work on preventing incidents. Second, human error is just a label. It's not a very helpful one at that. It is a symptom and not a cause. We learn only when we seek to understand how what happened. And finally, facilitated post-incident review is not the only way of responding to incidents, but it is one of the best tools we know about for learning. At its most effective, it can expose not only what went wrong, but what went right and how we can build on that. Thank you all so much for your attention. If I have successfully piqued your interest in this topic, you can find resources from the talk, as well as papers and videos which go far deeper than I have today at the link at the top. And I'd like to issue my thanks and call attention to a community of individuals from across the industry, including my colleague Jessica DeVita, people such as John Allspore, Nora Jones, the aforementioned Dr. Richard Cook. There are some incredible people who have turned their attention to these topics, turned their attention on these topics to our industry, and are talking about that at this link here, learningfromincidents.io. Thank you very much, everyone. I hope I have a question or two.
Thanks a lot, Nick. I'll give you my applause. I think
Thank
everyone does repeat that. Thanks a lot for the presentation. Let me maybe remove it so we can see each other. Yeah, we have two questions. I think we are a bit ahead of schedule, so we might even address a few of them more. So the first one comes from Jakub. What about the good old 5 whys technique? When you should ask how? Can this be 5 hows now?
This is a great question, and I get this question every time I give this talk. So yes, my feelings on the 5 whys are not particularly complicated. I don't think it's a particularly useful technique. There is underlying the history of the 5 whys technique something useful, though, which is to dig beyond the obvious answers to find more interesting things. So if what you take from the 5 whys technique is you shouldn't be satisfied with the first answer you get when you ask how something happened or why something happened, and you should dig further, then great. However, I will say that the idea that you can ask why 5 times in a row and somehow find yourself at the perfect place to intervene in your system is a little bit silly. Like it doesn't work like that. So I would say to Jakub, yes, 5 hows is probably better than 5 whys, but you can do even better than that and ask as many hows as you like, going down as many different side branches of the investigation as you like in order to understand all of the interesting things that happened. And I would strongly encourage people not to be bound by any kind of formula for how to do this, and instead to simply ask about the things that seem interesting to them or seem surprising to them in order to learn as much as they can from the incident in the time they have available.
Great.
I will add one thing to that, which is that on this precise topic, one of the people I mentioned during the talk, John Allspore, has a blog post somewhere called The Infinite Hows, which addresses pretty much this exact topic. So definitely worth a read.
Oh, great. If you could put it later on in the chat, we would be really grateful. So I think we have time for another one. That's one from Ola. Any advice on stopping the blame game?
This is a tough one. I don't know that I can give any generic advice, because it is going to depend very much on the environment that you're working in. If you're working in a very toxic environment where everybody after an incident is just trying to work out who to blame, I don't know that it's going to be really hard to fix that. It'll depend a little bit again on like who is the person trying to do the blaming. If it's from someone very senior and very powerful in the company, then you might want to look for somewhere else to work, because it's probably not going to get fixed anytime soon. But if it's not about that, and if it's more about just an honest misunderstanding for how these things work, then the 4 suggestions, the 4 helpful practices I've given here are almost precisely intended to address this question, which is, if you have a facilitator whose job it is not to be an expert, not to know what happened during the incident, but to ask people for their perspectives and to walk through the timeline of the incident and find out the complexities of what was going on during the incident, then when people see that for what it is and they see how the system really works, it will be very hard for them to blame. the example of the B-17s is kind of on this front as well, right? Which is like, it's very easy to say, oh, well, the pilot did something wrong.
Mm.
But when you understand the full story, which includes what they were doing, that these switches were really close to one another, that also includes facts like the Douglas Skytrain cargo aircraft never has accidents like this because its controls don't look anything like the ones in the B-17. When you understand the truth of what's happening, it just looks silly for you to point at the pilot and say it was their fault. So I would say that the best generic advice I can give is do the best job you can of telling the complex and interesting story of what actually happened during the incident. And then all of the people who are trying to blame will just stop talking because it'll be obvious to them that blaming isn't useful in the context of your situation.
Okay,
I hope that helps.
Yes, I think at least from my perspective, it addresses the question. I had the last one, maybe a short one, hopefully. Sure. So, out of the organizations, who do you think should be the facilitator? It seems like quite a lot of work, like time-consuming action, right? To talk with people on one-on-ones and so on. Who do you think could be the one? Like
I would. Yeah, I mean, I think who is best placed to do this will vary from organization to organization again. It usually shouldn't be a people manager, just because the power relationships, I think, will make things complicated. But if you have a group of people in your organization who are interested in this topic, maybe it's just 2 or 3 of you who are interested in learning more from what's going on during incidents, then sitting down with the 3 of you, reading through the ETSI debriefing facilitation guide, and just trying to support one another in running these things is probably the best place to start. No matter who you are, you can be somebody brand new to the company. And I say that because the skills of facilitation are, I think, almost entirely independent of the skills of being a software engineer. Not entirely independent, but they're very different skills. And you don't have to be the most proficient, most experienced engineer in the room in order to do a good job of facilitating. That said, I will say that if you can at least get some of your respected engineers into your little pool of people who are doing facilitation, then that will help to seed what you learn, both about the importance of this process and about what you've learned about the technical systems in both directions. So yeah, find the people who are enthusiastic about doing it and start small and start to support one another in learning how to facilitate. Probably don't let the CTO do it. That's about that's about all I can suggest.
Okay, great. Nick, thanks a lot. Thanks a lot for joining us today.
Thank you very much for having me.